Hi everyone. Um, we're going to finish up what our examples we had with solving exponential equations. I think we had done 5 examples. 1, 2, 3, 4, 5. So I wanted to pick up with example 6. And that is e to the power of x minus 7 equals 23. I'm going to add 7 to both sides. You do try to get the exponential part by itself as much as you can. And e to the power of x equals 30. At this point, I can't see any way of getting a 1-to-1. So what I'm going to do is take the inverse of the e to the power of x, which is the natural log. So the natural log of e to the x equals the natural log of 30. So I'm taking the inverse operation on both sides. Undoing e to the power of x. The natural log and e kind of cancel each other out. That's x. And the natural log of 30. All right, grab this calculator. Natural log of 30 is 3.401. That's an approximation. And just to check, if I take e, which is second, and then natural log, e to the power of 3.401, and then I subtract 7, I want to see how close to 30 that is. That's 22.99. That's good enough for government work. And example 7, the equation 6 times 2 to the power of t minus 5 plus 4 equals 11. All right, let's do some solving. And I'm going to subtract 4 from both sides. I got 6 times 2 to the power of t minus 5 equals 7. I'm going to divide by 6 here. I have 2 to the power of t minus 5 equals 7/6. Now, the thing I can do here is I can take the log base 2 of 2 to the power of t minus 5. I'm just kind of getting this so that we solve for this exponent here. That's how we bring that down. Log base 2 of 7/6. Now, I know this is t minus 5. I'm going to clear this, and I'm actually going to grab my other calculator, which has log base on it. If you don't have a log base calculator, you're going to have to use the changer base. You're going to take the log of 7/6 divided by the log of 2. But I'm going to take the log, so that's math, and then log base 2, and then I'm going to take 7 divided by 6, and I get t minus 5 is 0.222. Everything I do is going to be to the nearest thousandth, and I'm going to add 5 here and add 5 here, and t equals 5.2 approximately. T is approximately, and this is approximately 5.222. Now, as I check that, I'm going to take 6 times 2 to the power of 5.222 minus 5, and go down here, and then add 4 to that. And how do I get? 10.998. Pretty darn close to 11. I think that is good enough to check it out there. So, and when we're rounding, we're going to round that much. I got one more example to look at. 1 plus 0.10 divided by 12 to the power of 12t equals 2. Now, I think what I want to do here, now I've been using the inverse, but this is a weird number inside here. If I take 1 plus 0.1 divided by 12, that's 1.00833333, and that's a weird number. I don't really want to do like the log base 1.00833333. I think we could probably get something close to working, but it's not like it's the base is 2. This is a repeating decimal base, and that's going to be more than I want to take on here. So what I'm going to do is I'm just going to take the log of both sides. I'm going to take the log of 1 plus 0.10 over 12 to the power of 12t equals the log of 2. And that's log base 10. And I'm going to use the property that says I can take this, and that's 12t. I can put that in front times the log of 1 plus 0.10 over 12, and that's equal to the log of 2. Okay, see, all I did was take the logarithm of both sides. I can do that. That's just an operation. And now I'm going to divide both sides by this. Log of 1 plus 0.10 over 12. And this side, log of 1 plus 0.10 over 12. And when I'm done, I'll have 12t equals something or other here. And I'm going to just do that right now. I'm just going to leave everything in the calculator. I think I can do that. Let's take the log of 2. Close that. Divide it by the log of 1 plus 0.1 divided by 12. And then get that answer. 12t is 83.524 approximately. And then I'm going to divide by 12. I'm going to leave that in there. T is approximately, I'm going to divide this by 12, 6.960. T is approximately 6.960. All right, I didn't talk about this a little bit, but we had problems similar. We looked at compound interest a little bit. If we compound every month, and it's 10% interest, compound every month, how many years, basically, and you take 12, the number of times you compound a year, times the number of years, how many times, how long would it take to double? And it would take about 7 years. At 10%, it would take 7 years for an investment that you would have to double it, where it would equal 2. Where we have 1, and we double it to 2, would take about 7 years. That's kind of what that does. Now, the problems I would like for you to do in your assignment, let me write that up here. we are looking at page 395. So I'm going to do a new section. 7, 10, 11, 20, and then 21 through 45, I want you to do the multiples of 3. Alright guys, you take care.